The Pakistan Air Force's acquisition and operational deployment of the Chengdu J-10C, designated under the export nomenclature J-10C Vigorous Dragon, constitutes a foundational and transformative element of the nation's contemporary military modernization strategy, representing a significant qualitative leap in its aerial combat capabilities and marking a decisive shift from a platform-centric force to a network-integrated system of systems force. This procurement, initiated through a formal agreement and resulting in the delivery of the first squadron in the early months of 2022, is characterized by its phased and systematic implementation, aimed at creating a sustainable and scalable fleet of these advanced fourth-plus-generation multi-role combat aircraft. The strategic imperative driving this acquisition is multifaceted, encompassing the need to counter regional technological advancements, maintain a credible minimum deterrence posture, and achieve a measure of qualitative parity with potential adversaries by fielding a platform that excels in both air dominance and precision strike roles across the aerial, terrestrial, and maritime domains. The operational doctrine governing the employment of the J-10C within the Pakistan Air Force structures it as the premier air superiority asset, tasked with establishing and maintaining control over contested airspace. Yet its inherent design philosophy as a true multi-role fighter ensures its applicability across a broad spectrum of missions, from deep strike and interdiction to maritime patrol and anti-ship warfare. The cornerstone of this formidable capability is the aircraft's deeply integrated and sophisticated avionics suite, which is built around a core of a next-generation active electronically scanned array radar system. This radar represents a monumental advance over previous generation systems, offering a quantum leap in performance through its ability to electronically steer its radar beam without physical movement, providing near-instantaneous tracking and scanning capabilities. The specific advantages conferred by this AESA technology are profound and include an exceptionally long detection and tracking range against low observable targets and small radar cross-section objects like cruise missiles, a dramatically enhanced resistance to enemy electronic countermeasures and jamming due to its ability to rapidly frequency hop and its low probability of intercept characteristics, and the capacity to simultaneously execute multiple functions, such as tracking numerous airborne targets while simultaneously mapping the ground or guiding missiles, all within the same operational timeframe. This powerful radar sensor is not an isolated system but is seamlessly fused with a suite of other advanced sensors, including an infrared search and track system that provides passive, long-range detection and tracking of heat signatures, and an advanced electronic warfare suite designed for both self-protection and signal intelligence. The data from all these sources are synthesized and correlated by a powerful mission computer using advanced sensor fusion algorithms, presenting the pilot with a single, coherent, and prioritized tactical picture on large area cockpit displays, thereby drastically reducing pilot workload and enhancing situational awareness. This integrated data is then disseminated across the battlespace via a secure, high-bandwidth, low-latency tactical data link, which enables the J-10C to function as a key node in a network-centric combat grid, sharing its sensor picture with other friendly aircraft, ground control stations, and naval assets, and receiving targeting cues and off-board sensor data from platforms like the Karakoram Eagle airborne early warning and control aircraft, effectively allowing the fighter to engage targets it has not yet detected with its own sensors. The manifestation of this advanced sensor and networking capability in aerial combat is realized through the aircraft's integration with a family of cutting-edge air-to-air munitions. The principal long-range engagement weapon is the PL-15 Beyond Visual Range air-to-air missile. The PL-15 is distinguished by its combination of an extremely long effective engagement range, reliably estimated to be in the realm of 150 to 200 kilometers or more, and its highly advanced terminal guidance system, which incorporates a miniature active electronically scanned array radar seeker. This AESA seeker head provides the missile with a significant degree of endgame autonomy and exceptional jamming immunity, making it a highly lethal threat even against modern, agile fighter aircraft attempting to evade at the limits of their kinematic performance. For close-in, visual-range dogfighting, the J-10C is armed with the PL-10, high-off borezite, imaging infrared homing missile. The PL-10 represents the pinnacle of short-range aerial combat technology, featuring extreme agility enabled by thrust vector control, a lock-on after-launch capability, and a sophisticated imaging infrared seeker that is highly resistant to flare countermeasures. Its most critical tactical attribute is its ability to be locked onto a target that is at a very wide angle from the aircraft's forward axis, allowing a pilot to engage an adversary by simply pointing the aircraft's nose in the general direction for a brief moment, without having to maneuver into a traditional tail chase position, a capability that fundamentally alters close-range tactical engagements. For the execution of maritime strike and anti-ship missions, the J-10C can be configured with specialized air-to-surface munitions designed to neutralize naval surface combatants. The primary weapon in this arsenal is the YJ-91, a high supersonic missile derived from the Russian Kh-31 design but extensively refined. The YJ-91 is operational in two distinct, mission-specific variants. The first is an anti-radiation missile variant, designated YJ-91R, which is designed to passively home in on the radio frequency emissions of enemy naval radars, surface-to-air missile systems, and early warning radars, thereby performing a critical suppression of enemy air defenses and destruction of enemy air defenses role. The second is a dedicated anti-ship variant, the YJ-91A, which employs an active radar seeker to locate and track maritime targets amidst sea clutter, and its high supersonic terminal velocity, often exceeding Mach 2.5, drastically compresses the target ship's reaction time and improves the missile's probability of penetrating layered air defenses. Beyond this specialized anti-ship missile, the J-10C's arsenal for land attack and naval strike is further expanded by its compatibility with a wide range of other precision-guided munitions, including the KD-88 television or imaging infrared guided air-to-ground missile for engaging high-value fixed targets, laser-guided bombs of various weights for close air support, and satellite-guided glide bombs for all-weather, standoff precision strikes against infrastructure targets, making it a versatile platform for coercive diplomacy and conventional deterrence. The platform's physical design incorporates several features that contribute directly to its combat effectiveness and survivability. A key innovation is the diverterless supersonic inlet, which replaces the complex, heavy, and radar-reflecting intake ramps and diverter channels of earlier fighter designs with a sleek, computer-optimized bump that manages the airflow and hides the engine fan from radar waves, simultaneously reducing weight, maintenance complexity, and the aircraft's frontal radar signature. The airframe itself makes extensive use of composite materials in its primary and secondary structures, resulting in a lighter airframe with greater inherent strength and increased internal fuel capacity for extended range and loiter time. Propulsion is provided by a single WS-10B Taihang turbofan engine, an indigenously Chinese-developed powerplant that delivers high thrust-to-weight ratios and reliability. This engine is reported to provide sufficient excess thrust to enable the J-10C to achieve a supercruise capability, which is the ability to sustain supersonic flight speeds without the use of the fuel-intensive afterburner, a characteristic that provides significant tactical advantages in terms of rapid ingress or egress from a combat zone and improved fuel economy during high-speed interception missions. The future trajectory of the J-10C program within the Pakistan Air Force is one of continuous evolution and expansion. The current plan involves the ongoing, phased induction of additional aircraft batches to equip subsequent squadrons, systematically building up to a planned fleet strength that will form a significant portion of the PAF's high-end combat power. This expansion is accompanied by a parallel, and equally critical, investment in the entire ecosystem supporting the platform. This includes the establishment of comprehensive pilot and ground crew training programs, often utilizing high-fidelity simulators linked through networked training environments, the development of an indigenous depth of maintenance, repair, and overhaul infrastructure to ensure high fleet availability rates and operational readiness, and the creation of robust logistical supply chains for spare parts and munitions. A defining feature of the aircraft's design that shapes its future is its open architecture avionics and mission systems, which are fundamentally designed to accept incremental software updates and hardware upgrades throughout its service life. This forward-looking design philosophy ensures that the J-10C fleet will not remain static but can evolve to integrate next-generation weapons, such as even longer-range or networked missiles, more powerful radar and sensor processing capabilities, and advanced defensive countermeasures, thereby ensuring its relevance and combat effectiveness for decades to come against an ever-evolving threat landscape. The program, therefore, is not merely about the acquisition of a new fighter jet, but represents a long-term, institutional commitment to mastering and advancing a complex, network-enabled weapons system that sits at the core of Pakistan's modern air power strategy.